So we're gonna try to do something a bit more professional. So not professional, but where did I have all the stuff? Where did I have all the quantum inclusion projects or workspace? Uh, I'll just make another one for camping. So basically, what I want to do is I want to try to do something a bit more not formal, but I want to take a look at my idea for quantum counting, and then try to take a look and see if I can get some accuracy numbers or something like that. So if you remember well, in my bookmarks in the workspace here, I should have quantum counting. So I did these thing here where I was like, okay, so based on the distribution of this qubit, you can directly map that to how many elements are flagged by the Oracle in Grover's algorithm. So I want to take a look. I want to basically code that in Qiskit and see if I can run through different amount of qubits and then see how the accuracy of this method works when we've got also maybe some error model in there. I don't know if this is the right way to approach it, but let's see. So where do I have the Jupyter notebook? Did I just overwrite it? Yeah. Okay. So we're gonna create a new notebook. Okay, and I think I'll probably have to. So to get a quick start, I'll probably go and copy paste the stuff that's in the quantum counting in here, because we need two things. So we need a function that, for this to run smoothly, I want a function that runs that builds me an oracle that just flags one element, but for a given amount of qubits, and then we need a function that builds a diffusion operator, not diffusion operator, the Grover part, the inverse about the thing. Where quantum? What did I do? Quantum counting. Yeah. Quantum counting. Let's just copy all that stuff. I probably don't need half of these things, but and what do we do? So example Grover iteration. Okay, so there's an entire function in here. So they do it in one function. So I want to have, okay, so that's the Oracle part in here, and that's the, so I want to have here the amount of qubits, right? So a quantum register. So this is basically what I want, and then I want to have X. Oh yeah, that's gonna be. So how do they build this CC? Is it? Because I'm gonna need to build a multi-control Z gate. Why is it underscore? Why is it underscore? Maybe I'll just go with that for a moment, and then I'll try to generalize these. Oracle. What does this Oracle do? Hotmart. Hotmart. Yeah. Okay, that's some kind of fancy, I'd say, Oracle. I just want to have, so I ideally just want to have a, to be honest, I just want to have, so for qubit in Q, for each qubit, I want to have circ an X gate, okay, on Q, on qubit. Oh, okay. Sorry, this is not the oracle. That's this part in here. So that's the diffusion operator. So I want to have for each qubit in Q an X gate, then I want to have here the actual super the multi-control. So what is these though? Circ. I don't understand this. What is Qiskit? X. Multi-control topology. Maybe this is a generalized already. What? So I can actually add as many CCCs as I want. No, multi-CX. Okay. Multi-control Toffoli gate. It's cool. This is all given already. So this is the 3-qubit controlled NOT. A 4-qubit control NOT. Multi-CX. Construct a circuit from multi-qubit control NOT. So your first argument is the circuit, then the list of registers. List of quantum registers of at least one length. A quantum register can be okay, and then CLA can be known if length is smaller than 5. What's next? Recursion. Okay, so it builds these things in here. I'll probably need a bunch of ancilas. How many will I need? So I think it was, so if I'm doing these, if I'm doing quirk, so if I'm going to build it like these, right? That's going to be an ancilla. That's going to be an ancilla, right? So I'm doing kind of, so for example, for 1, 2, 3, 4, 5, 6, 7, we've got 2 ancillas. Maybe I just should. How many ancillas do I put in here? Quantum can be non. if length QRS is smaller or equal than 5. But it's a length of, this is a list of quantum registers. List of quantum registers at least length 1. We'll try, okay? See what happens, but we might need to have some extra work qubits in here. But I could just basically call these. So let's see if these work. So I want an X gate for all these, then I want a multi-C X. Now I'm going to pass it the circuit. I'm going to pass it the quantum register. This is Q, and here I'm going to pass it non. I'll just leave it like this. And now I want the same like here, right? And let's test that out quickly. Return the circuit. So if I just go here and say C equals, oh no, C equals this, and I want 3, and or I'll just say draw these with output. I think it was MPL. Could it be? Draw is not defined. What was the drawing part? Circ draw. I gotta do it like this. Sure. It's draw output MPL. It's not name multi, and multi CX is not defined. Do I have to import this from Cisco for Qiskit Aqua multi-control? Should I just import this stuff? Because in here they use it. Oh, okay. So I'll just import the. Okay, so it's not this is what I need to import. It's this what I need to import. Exactly. Oh, neat, beautiful. So what happens if I increase this number to 5? What? That's monster. Okay. That's insane. Okay, so 3 is already the. That's a monster. Oh, because it's messing up here with this. Let me add a barrier here. So let's say here circ barrier, and here after this is circ barrier. I just want to make sure that this doesn't mess up exactly. So this is the actual. So if I do something like 6, it's already okay. So here already need ancilla qubits if I'm above 5 qubits. Okay, cool. So we've got this now. Now the oracle. So how do we do the oracle? The oracle. So I'm tempted to do it a bit more generic because I wanted to be able to flag as many elements as possible. But we can start just with one, which essentially could be, it could just be the actual an actual multi-control Z. I don't know if there's like multi-control Z. Does something like this exist as well? in here that I could just import and use. Well, at the end of the day, it's just a multi. Okay, so it's just a yeah. I could do a Hadamard in the last qubit and then do a multi, and then use the same thing here, and they should be the same. So for the moment, we're gonna just flag one element because we can stick to this. We can try to stick to just just checking with this one element for the moment. Although I could easily say NB qubits and then NB values, right? So how many values do I wanna? How many values do we want to? How many values do we want to flag? And so it's essentially you would construct this oracle because this is a pretty nasty, not nasty, but it's a pretty weird. Seems a bit of an optimized way of building this. Ideally, I would just iterate for. It says like I'll go for I would iterate over these values, and then each value I would just encode it. So I would just flag the element 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 exactly. And I ideally should add a check that the NB values cannot be bigger than the NB, the 2 to the power of NB qubits. Otherwise, I would just show an error. How could we do this? So how could we? How could we just output an error? I mean, I'll just go the stupid way and just print stuff. So if NB values is basically bigger than 2 to the power of NB qubits. I think you do it like this. NB qubits. And basically print too many values. Pass or it's pass in Python. Python pass. Nothing happens. What if I just want to return nothing? Python return. I'm learning Python as well as I do this, right? Python return. Or an error. Like, should I just could raise? You could raise value. Okay. You could use raise value error. Okay. So I could just say raise value error, something like this. Does this work? If I now say, I don't know, for example, 200. What? The examples here 2 were given. No. What's the invalid syntax? Should I do this? Yeah. Value error. Too many values. Python is an exception. Cast a message. How do I do that? What? Raise value error. Raise value error. How? Raise value error. Is it just Alt? Python 3 value error. I don't know. I'm doing something. Some places in here I've seen. Yeah, whatever. I'll just comment that for now. But otherwise, what we do is what do we do? What do we do? So we do a for. So do we just do a how do you, so this is Google search programming. So how do you Python for loop? So I just want to have a for x in, okay, so for basically for x in oh, but I don't have a range. What I do want to have is for range 3. Does this work? In values, basically, and now I can just print x. If I do something like this, do I have to end? Do I have to end if or something? Or I just probably have to return null or something, return 0, whatever. Int x. What? Keep it in queue. What am I doing here? What is the return circ? Circ. Executed. We're not supposed to return. Why? What is it doing? Oh, sorry. So say 2, for example, right? But why I can't see? Can't I see prints in here? Anyway. To work. So good. Then basically for these. So what I want to have now is I want to have a binary. Can I have a binary representation of these? Or can I have a? Because I basically want to have. For each of these values, right? It's basically a multi-control Z. So what I know for sure is that in the last qubit, so I have number of qubits. So basically in the circ, not circ, but in the circ Hadamard of NB qubits minus 1, right? And so this is going to be, and so now here goes the multi X, and then I got another one in here, exactly. Now the trick here is the multi X basically is got to have a pattern of, if it's 0, then I want to have all of those. So 0 is a special case, right? Because it's basically, so if X is 0, that's a special case. Because here I want to have can I specify a multi? Can I specify if I say circ? If I say circ X gate and I say range, can I say from 0 to NB qubits minus 1? Does this work? If I do this and I add a 1 element, I think so, but let me add a barrier here. Circ, I'll tell you, so barrier and circ barrier. And NB qubits, right? Okay, that works. If I do 2, if I do like 3, okay, so it's adding, this is what I'm trying to do here, it's adding all this here, all this layer of X's in here. Because I will need that for then I go on with my with the multi-control X in here. Okay. And if it's 0, I add another sandwich after that. So exactly. So we'll go here in between. Why do I have another Hadamard in here? I don't understand. This Hadamard, this. What is going on here? Is it because of if I so why? Oh yeah, because this is for each element that I'm doing. So I'm doing in NB values -1. So that's what I want to do. I just want to have one. And here I'll copy that. What? Okay, so good. This is probably going to be the most inefficient code to generate this circuit. And then here now I need a multi-control X, which is basically, well, I could have just, well, I could have just, well, you know, do a, why is it, so I can just also do multi-control X here and just have the 0 case separate, honestly. It's going to make it easier. And then say else, and actually do the rest, right? And how would I do that? So in this case, the else, what I should do is I should basically, it's a similar idea, but I need to, what I need to do is I need to wrap only some of those controls with X's, right? Because I want to have, for example, I want to have something like these, right? Say, for example, right? So this is the same as doing these. And so how do I do these? How would I do this? So I would just, I need to know in which position of the binary representation there is a and let's make it easier. Let's say I don't want to overcomplicate that, to be honest, because I would also then have to consider where the Z is going, to be honest. So I probably am better off if I control on you know what? If it's over, then I'll just return one element flagged, which is basically these for now, so I don't get weird exceptions. And now I basically would need to know in what position there are zeros, and in these positions, then add the not sandwich. So by how can I iterate over? So I should convert that number x into binary. Then I should basically get the iterate over the digits, and then if it's 0, basically, yeah. So So where do I even start? So Python converter binary. Python iterator over binary digits. The bits of an integer. Iterate over. No, I wanna. Bitwise should be a NOS. Bit manipulation. Strings to integers. Yeah, I could also just convert the string and iterate over this. Python binary to string. Can I do this? I need the string. Binary value. Come on, that shouldn't be that complicated. Int to binary string. Yeah. Python's format method. So that works or what? So if I take these. Let's try it out here. I say does this work? Okay. Cool. Okay, that works. Perfect. So I can say basically the binary X string is basically these, and now I can say, so and if I do these, can I just do, so this is 11, can I just do these, this is these, and for each or something like that? Or for bit in these, print B. Yeah. Okay, cool. You can just copy these, basically, and say so now I've got I've got basically, so if it's a 0, if these a 0, if it's 0, then we want to have a circ x for we are right now in, so for x, I should use better naming. Exactly. Oh yeah. Then we do basically a circ here. Then we do a multi-x We do a circ rear, just make sure we're drawing things correctly, and then we basically repeat the sandwich, right? So we repeat the sandwich, and there we go, and I think we're done. So if I basically say now that I want, for example, three qubits, and I want two values flagged. So what is it doing? Not format 2, but format X. So, that's nice. Okay, let's see. No, that's not working. So, first of all, it's missing a barrier here for clarity, exactly. But that part in here is missing the Hanamarts. So what is it? The Hadamard is the second time, so that's 0, and that should be 1, right? So how do I debug this? Cannot take that long. So basically, multi-x, x equals 0, else for x in range, okay? So x should be 1, and then basically that should apply again. Why am I not seeing the Hadamarts again? That's what's interesting. So let me test these for a second. So let's take a look at these. Diffusion operator. Oh, wait a second. Okay, so that's the actual diffusion operator. That's why you don't see the Hadamarts in here. So is it that is this working like that? It's something's off in here. I'm missing an X gate. So this is the first here, the first Hadamard, and this now I'm missing here an X. If B equals 0. Maybe I should just it's just a matter of the naming here. I should be B. Oh, format X, damn it. Should work now. 0, 1. Okay, if I do 3. Come on, the X is not here. The circ X goes not to X, but goes to it goes to the bit position in here. So how do I know the index of B in this case? I'll just say n. So lame. So it's basically I, and basically I plus plus. If I just do this, that should work. Just lame, get it done fast. Doesn't work either. What? If b equals 0, oh yeah, of course. Well, here you go. Should increment these regardless. It's it's again you putting the Hadamard's in the wrong place. Circ X on the qubit 0, and I 1 on qubit and I 1 on qubit don't tell me it's doing it. Oh yeah, it's starting from the highest. Okay, so basically what I should do is like this is NB qubits minus I, correct? No. What am I? What's the syntax? Let I. Why not? Is it like this or what? Let I be 0. Why isn't it like this? Say I 0. I equals 0. Can I just do it like this? I, or what? You should be able to do that. It's not doing what I wanted to do. Maybe I was right here from the very beginning. Yeah, of course, because I'm stupid. Here we go. No, something's wrong. There should be 0. Here there should be I minus 1. This is the worst code ever. Is this here though? What I don't get any. So this is for 0. This is for 1. I don't get it. Oh, that's correct. So if b equals 0, then just put the x on the damn qubit 0 and get done with this. Why isn't it putting x gates in here, but yes, in here? I don't get. 4. So if I'm doing format on 2, right? Now it works or what? I don't get it. First, you've got a 1. It doesn't matter. I mean, yeah, actually, it's correct. X and B values. So the first X is going to be a 0, the second X is going to be a 1, right? So if you do like these, yeah, then a 1 is going to print 1 is going to print a 1. So there's no 0 in it. Okay, this is probably this is not needed at all. I just overcomplicated things, and all I showed is that I'm bad at coding. So anyway, we'll leave it like this, and so the idea here is now you can basically flag here an arbitrary amount of qubits, and then have that keep it to 1. So and then basically have Grover's iteration do that. Good. And so the next thing that I wanted to do is the next thing that I wanted to do is what? The next thing that I wanted to do is basically get the where was I putting it all together? So the gate thing, I want to basically exactly, so these I wanna get these exactly. So now I've got basically these. Now I can create a control. What if I do C grid draw? Output equals NPL. I cannot draw that. Why? Because that's just a gate. Okay, so that's just a gate. And now I do a how can I use this now? I can probably use, so initialize all the qubits with a Hadamard and then begin the controlled operations. So if I now say basically quantum C equals quantum circuit with 4 qubits, okay? And then I do C Hadamard for range 1 to 3. And now I do C, basically how would I apply the C grid? Like these, okay. Q arcs. Qubit, so the control qubit and the other two. You do it like this. So this is the qubit. So this is the qubit I would say 0, and this is the qubit. And this is basically range 1, 3, correct? Boom. 1, 1, 3, this is going to be converted to a gate. Why? Okay. Here. So this is just like this stuff in here. So let me, can I delete? Can I delete the cell? Cell, edit. Delete cells, edit, delete cells. So I cannot turn that into a circuit, or what? Maybe the barriers. Maybe the barriers cannot. Okay. So what if we comment out all the barriers? Barriers, barrier, 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 barrier. Barrier out, barrier, 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 barrier out, barrier out, barrier out. Barriers. Oh, good. Good. So can at least not range to least. So if I just do 3. Ooh. Draw output equals NPL. Okay. Range 1, 4. Okay. So in theory, that's the circuit, right? And now I would like to basically apply a Hadamard. I'd like to apply a Hadamard to the qubit 0 after that, right? And that's the qubit that I like to measure. So basically, this is going to just have one classical registry, and then we're going to see and do the measure from 0 to 0. Cool. And now I should be able to sample this. Let's give a quick try, and I'll just basically stop here. So for now, and then we'll try, and then the next video, we'll try and take a look at this and then build up that function in here that is just a disaster. It's just a pure disaster. But basically, if I now do that, if I now do what, how was I measuring? How does this look like now? The QASM simulator. I just gotta keep copying that all the time. So get the QASM simulator. We're gonna do it 2,000 shots, and then this is gonna be C, and then we're gonna plot the histogram. 50-50. Now, that doesn't seem to be what I expected. That doesn't seem to be. So I flag one element in all that, right? So I basically did these, and I just flagged. Oh, sorry, that needs to be in yeah, sure. Sorry. So yeah, that's how it should. Yeah, okay. So that seems to match my results. 0.126, right? So if I do one element in here is, no, that doesn't match my results, does it? 87%. So this is in the plus state. This flex one element. 74. It seems to be the opposite. I don't know why. It seems to be the opposite. If I do 1024, it doesn't change much, right? But does change again. If I do 100 shots, if I do 8,000 shots, what am I doing wrong here? So am I doing anything wrong? So I've got the circuit in here. Those are all in Hadamard. So it's this is in the plus state. This is the control qubit. And I'm measuring this qubit. It seems to give me the opposite effect of what I would expect. AA1. So that just flags one element and does amplitude amplification. I think I'm not doing amplitude amplification correctly. Of course I'm not. So this is basically, I need to add, before the x's, I need to add Hadamards, my friend, and after the x's, I need to add Hadamards. Now, and now it's messed up. So this is these, and then it's there's one Hadamard too much in here. I know, because this is this Hadamard in here. Okay, but this x shouldn't be here. To be honest, can I just trash that? Can I? Can I just trash that and then just have a so this is just Hadamard in the last qubit, right? Please, I don't understand. Yeah, so this is just two Hadamards, and then now I will do a basically OPX. Okay, let's just let's just do it like this, okay? So I spend all the video doing that, and then I'll just trash it. Good, I'll recover it later. Let's get rid of the barrier. No. But it's still not good. It's still definitely not what I expected it to be. It's definitely not what I expected it to be. Okay, I'll leave it here. I gotta work on this a bit more. It's 37%, so 40% roughly. So it's not matching what I expected it to be according to Quirk, right? I'm trying to build these basically. Anyway,